come to see the drawing structure so far. I want to reiterate those again. Before we do that, we got to start at the tippy tip top. Rewind the wheel back really far. What are the two types of chemical bonds we talked about in this class? Ionic and covalent. We got ionic. We also have covalent. What determines what? What terms ionic? What terms covalent? Mr. Long? You're there. It's in the brain. I just caught you off guard. On your heels. Can you recover? Non-metal to metal is a what? Ionic. You asking me or you're telling me?
Ionic.
So non-metal to metal is an ionic bond. What makes a covalent bond? Non-metal, non-metal. Says Valerie really quietly all the way up in the front. Non-metal to non-metal. Okay, how we draw our Lewis structures looks a tad bit different when we do these. Okay? Make sure you pay attention. Your brain literally cannot learn. Educational psychology says you cannot do two things at the same time and form new connections in your brain. Just cannot happen. You can multitask two things if you've done it before, like fold laundry and listen to music, but you cannot learn and listen to music at the same time. Somebody feel personally attacked by that one. You might feel like you're studying by listening to music, and an educational psychologist shut you down all day long. So, ionic, non-metals to metals, covalent non-metals to non-metals. So when we look at Lewis structures for ionic compounds, the very first thing we do is we draw our central atom and how many electrons it's bringing to the party. So the first example I'm going to do, I need to grab my periodic table. I don't know where it went to. Right here. Kai stole it. Okay. Come on, jeez. Okay. First, what I'm going to do magnesium chloride, MgCl2. We'll do this example. First thing we draw is we draw our central atom and how many electrons it's bringing to the party. So we got magnesium. Looks great. How many electrons is magnesium bringing to the party? Might need practice for this one. Unless you have Mr. Williams got it tattooed in your brain. Magnesium bringing how many electrons? 2. Somebody tell me what I did wrong. I drew 2 valence electrons on that magnesium. They're too close. They need to be what? Spread out as far as possible. So I'm going to go do that. I'm going to spread 1 over here, 1 over here. Looks great. Let's look at chlorine now. How many electrons is chlorine going to bring to the party? 7. So let's draw a chlorine atom next to that magnesium. And let's give it 7 electrons. So chlorine is going to rip away 1 electron from magnesium. It's going to be full, it's full 8 electrons. We're going to do the same thing to the other side. Chlorine. Draw it with 7 electrons. There you go, we're done. Here's where students are getting the mistakes from. Here's the number 1 mistake I've seen. Ionic bonds are not like covalent bonds. They do not follow the rule of 8. You just make them happy. Magnesium has 2 valence electrons, we know this. Let's go to 0. Chlorine has 7. Once you get to 8. So chlorine rips away the 2 from magnesium. Now we got our ionic bond here. So this we can draw. I'll scroll down just a little bit. we can also draw like this. This technically is not considered correct because by drawing it this way, we're writing it as a bond, but it's an ionic bond. They're not sharing those electrons, they're being taken, but it can help you see how many bonding sites you have. How many bonding sites do we have on that magnesium? We got 2, right? So that helps us determine what our shape is. This is what students are doing wrong. I'm about to do some bad stuff on the board. Don't write it down. This is what I see. Mr. Williams, magnesium needs to say, now we got too many electrons. I'm going to start drawing some double bonds in there. Bad chemistry. We want to leave it as this. So we have 2 bonding sites, which means we make what kind of shape? They all cried out in uniformity because they're ready for chemistry class today is linear. Not too crazy, not too bad. Okay? Should we do another example of ionic before we move on to covalent? Or do we feel okay? I just need like some heads up or like we feel okay? Okay. Do we see how we can easily mistake this for 8 electrons here and think it's covalent and just don't do that, right? Let's do 2 covalents now. Let's do an easy one we've done before. CH4. Countervalence electrons, that'd be 8. Looks great. We would draw Lewis diagrams. Carbon is great. But Mr. Williams, hydrogen is on the left side of the periodic table. Hydrogen is the only nonmetal on the left side of the periodic table. And we only give hydrogen 2. How many bonding sites you got here? 4, which makes it tetrahedral. They all clamored in uniform excitement. I'm so excited about writing tetrahedral, I'm spelling it wrong. Tetrahedral. Good. One thing I forgot to mention, but let's rewind just a little bit. All right, the first element is going to be most likely your central element. So we put in magnesium in the middle, carbon in the middle. Looks great. What happens if we have a polyatomic? Like CH3OH. We start off with carbon. We draw its 3. Start off with carbon. Draw its 3 hydrogens. Hydrogen, hydrogen, hydrogen. Its 4th thing, its 4th atom attached to its oxygen. And attached to that oxygen is a hydrogen. That's great. However, since this is a covalent bond, I'm missing some things. What am I missing? I'm not finished. Almost the way there. Brandon, do you know what it is? Absolutely. On what element? Oxygen. Fantastic. We need to put our lone pairs on the oxygen. And this will help us figure out our shapes. We technically have 2 shapes here, right? Carbon's got 4 bonding sites. 1, 2, 3, 4. Let's do 1, 2, 3, 4. None of them are lone pairs of electrons. So that makes us be tetrahedral in shape. The other one, however, how many bonding sites are on that oxygen? This is probably the other big mistake I've seen. If I had a list of the 10 things students get wrong, 8 of them would be right here. How many bonding sites do you have? We have 4. Make sure we don't count those. Remember, bonding sites where bonds could be, not where they are. Where could bonds be around this oxygen? 1, 2, 3, 4. But since I have 2 lone pairs of electrons, what is my actual shape? And that's going to be bent. Okay, it's going to be bent. I'm going to come back here in a second, but I want to talk about one thing real quick. We haven't done this for a while, but we did talk about when we introduced water molecule. Early in the class, I would just give you the molecule drawing, and then you draw it. One time we drew water molecules, we talked about polarity, non-polar and polar. Right? Now, since we're drawing molecules, that naturally bubbles up and it comes back. How do you predict polarity? Well, you try to see, is there symmetry in the atom? Check this out. If I were to draw an imaginary line through this carbon, do you see how there's some symmetry to it? Split the hydrogens down the middle, we got one hydrogen on the other sides. What if I were to cut it this way? See some symmetry to it? Hydrogens balance on both sides. In balance, meaning there's no polarity to it. Like, think of bipolar, like north and south poles, bipolar. Bipolar disorder, happy, sad. Okay. Bipolar means there's a positive and a negative side. There's something that is asymmetrical about what you have. Since this is a symmetrical molecule, this is non-polar. Because there is symmetry to that molecule all the way around. What about this molecule down here? Is there symmetry about each atom? If I were to draw an imaginary line through the carbon here, I'll do different colors. Let's do we have pink in there already. Is there symmetry about that blue line? No. What about this oxygen? No. So since there's a way for us to draw that there is no symmetry, we're going to then label this one as polar. All the boo-boos I've seen so far in the homework. Right. One of them is being able to count your sites correctly. Second one being is reminding you that if it's ionic, how you draw your bonds looks a little bit different. If it's covalent, how you draw your bonds is a little bit different. And the one thing I think everybody need a nice little refresher of was polar versus non-polar, which I'll admit we haven't done in a hot second. Okay. But I'm going to give you... we both do that. Okay. I'm going to give you the rest of the class. I thought we should have 20 minutes. 10 minutes ahead of schedule. That's great. Awesome job. Okay. I'll give you the rest of time to work on your reading, work on your homework, ask whatever questions you have.